All right, let's go ahead and get started. I'd like to thank everyone who's joining us today. Welcome to today's CNCF webinar, Optimize Your Kubernetes Cluster on Azure with Built-in Best Practices. I'm Karen Chu, Community Program Manager at Microsoft and CNCF Ambassador. I'll be moderating today's webinar, and we'd like to welcome our presenter today, George Palma, Senior Program Manager at Microsoft. And just before we start, a few housekeeping items. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop in questions there, and we will get through as many as we can at the end. This is an official webinar of the CNCF, and as such, is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of the Code of Conduct, and basically just be respectful of all your fellow participants and presenters. Please also note that the recording and slides will be posted later today to the CNCF webinar page at cncf.io/webinars. And with that, I will hand it over to George to kick off today's presentation.
All right, can you hear me well, Karen? Awesome, thank you very much. So good morning, everyone. My name is Josh Palma, and I'm a Senior Program Manager in the Azure Container Compute team. More specifically, I'm one of the product owners of Azure Kubernetes Service. And as Karen mentioned, today we're going to talk a bit about how we can optimize our Kubernetes clusters and our production workloads running in production Kubernetes clusters. So without further ado, jumping right through it. So most of you are here, so I'm guessing if you're interested in all, or at least a big part of the amazing capabilities that Kubernetes brings us and delivers us in terms of portability, extensibility, and all the goodness that it brings into running applications, cloud-native applications at scale. But one thing that it doesn't effectively bring to the table or claim to be is super easy to start, super easy to get started, or not complex at all to understand. So it can seem a bit daunting at times, and we've seen that time and time again, where those 5 little core components that Kubernetes kind of is comprised of, plus all the additional new core components and all the ecosystem that surrounds it, has become a bit daunting for folks to really get their a good depth into, and then that can kind of put them a bit off into actually adopting the technology kind of more in a more faster manner and more confidently as well. And at the same time, we've seen that there's been a lot of concerns around how to actually manage such a Kubernetes cluster. In particular, things like the control plane, like do you have the right high availability considerations in place? Do you have the right hardening considerations in place? Are you secure? Are you hardened? Are you protected? And are you scalable for the needs of all essentially your users and your enterprise as well? And so this is kind of seeing the rise of managed Kubernetes offers across the board, where effectively the promise is very simple and appealing, and it's just like, okay, so you get kind of the goodness of Kubernetes, and you essentially get a Kubernetes API endpoint, and you kind of abstract the rest, which is handled by a service provider for you, and then you can kind of focus yourself into actually delivering the impact and the value, which is actually running your applications and your services inside of Kubernetes and using it without having to effectively care about those nitty-gritty details. But is that then everything that all there is? And we've come to see more and more people realizing that no, it isn't. In fact, if we kind of take a step back and look a bit from a bigger picture view and focus on what we actually want to do, which is the end goal is not really just to run a great Kubernetes cluster, but actually running applications inside such a cluster, confidently running production, be able to scale massively and respond to the business needs. Those are the actual objectives that normally folks are tasked with. And so those actually have a bit more of components that you need to look at that are not just core to Kubernetes. So you need to look at, is your full environment secure? Do you have good governance across both this Kubernetes cluster, this kind of one that we've been talking, but also across your fleet of potential clusters, as well as to the fleet of potential resources that you're using with your clusters? Do you have a good identity mechanism? Are you effectively day two processes, your governance processes, matching your company's needs and effectively what you're required to do in terms of compliance and standards. And similarly, are your development processes matching? Are your people and your tools well adjusted into what the new processes are required to be in this kind of cloud native world? And more often than not, we've seen that there's a lot missing, and there's a lot of common issues that we see. So some of them obviously are kind of number one, derived from incorrect Kubernetes configurations. And so just because if we assume like the managed service, for example, that doesn't take away all the knobs that you need to tweak. In many cases, it takes away a lot of them and provides you already configured. But in many cases, your workloads and your actual requirements will make you have to tweak some of these configurations. And in many cases, that exposes you to potential either mistakes or complexities of the Kubernetes configuration model, which can again throw you off and kind of into a slope of this enlightenment from what Kubernetes actually can give you. Another thing that's been seen a lot, the community has been discussing quite a lot, is the fact of a lot of clusters having very permissive kind of role access, security, access controls, as well as effectively just being plainly insecure, not having any sort of pod security or cluster security thoughts behind it whatsoever. And kind of tied to that is the lack of governance policies. So again, very rarely we've seen effectively users that have only one Kubernetes cluster for their entire use cases. Rarely we've seen enterprises that have one Kubernetes cluster for absolutely everything, all their environments, all their business units, all their applications. And as soon as you start discussing, or especially as you start discussing more than one cluster and you start looking at a fleet of however and how big they might be, governance becomes absolutely fundamental to your normal day-to-day business and to actually keeping those clusters running and secure. And tied to that, a lack of kind of central authentication and access control at scale, which is obviously Kubernetes provides you already with the knobs and the actual plugs to get in, for example, central authentication directories. It already provides you with Kubernetes RBAC, but in many cases, and again, once more, especially at scale, we see those controls kind of be diluted across just for sake of operational simplicity and to kind of make everyone's lives a bit easier. And those shouldn't be trade-offs, really. And so we're going to look a bit into how we can actually go back into that kind of best practice without actually having to suffer from it as per se. And then the last two are effectively something that I believe everyone wants, which is making sure that the disruptions and unplanned downtime are kept to a minimum and that they don't affect you a lot, and that you're in cases where you're being inefficient, you're able to get that efficient backup. So again, get the best usage of your resources, in this case, it's your cluster, maxed and optimized. So what actually can we do and what are the needs that we have? So obviously, if one of the problems is Kubernetes configurations are incorrect, what we need is validating them, right? And similarly, if a common set of issues are around the container cluster security and pod security, again, the solution is to manage them. Now, you might say, okay, George, you're just literally answering your questions with themselves. But we'll take a look a bit into what does this actually mean, because there are actually a lot of solutions out there already that deliver a lot of these same needs. But especially when you look at them at scale, there might not be that much approach. There's not a lot. So if you actually look at, for example, the CNCF webinars, you have great content for pretty much absolutely every single one of these points already. Today we're going to look at them kind of holistically, and we're going to approach them again in the full spectrum. And if we move to the next one, have a curated set of secure configurations, and that you are able to enforce them. Again, via the first hint of what we're going to be discussing today, which is policies. So essentially having policy enforcement and policy management. And then number 4, again, as I hinted before, leveraging authentication directories, make sure that you're able to apply the fine-grained access control at scale, and minimize the human errors, which are normally the biggest causes of issues in a properly configured Kubernetes cluster, and make sure that it's hardened against disruption with things like make sure that you have pod disruption budgets to avoid that these kind of voluntary disruptions or kind of simple mistakes don't affect your cluster. And then the last one is something that has been approached a few times already, and I'd like to take a slightly different angle to it. So it's how can we be more efficient, for example, from a cost optimization perspective. And obviously the first thing that comes to mind is immediately, okay, so we use auto-scaling, obviously. But sometimes it's not just about auto-scaling per se. Obviously, it comes to mind, do you have horizontal pod autoscaler and cluster autoscaler configured are normally kind of just the kind of template answers, and that's it. But in many cases, that doesn't give you the last mile of optimization. Those are, again, given. You absolutely should if you can have those two solutions running, and those will deliver, I believe, the greatest amount of benefits. But then you can actually go a bit beyond that, for example, by optimizing based on your workload, tuning, for example, the autoscaling capabilities based on your specific workload so that the cluster scales a bit more closely to what your workload needs are. And similarly, making sure that your actual infrastructure is also optimized for your cluster and for the different workloads on your cluster. For example, if you have different needs in terms of agent nodes, from a hardware perspective, making sure that you don't need to kind of just default to the bigger one or default to the more specialized one. You can actually mix and match within your cluster, which is something Kubernetes supports very, very nicely, and have different agent groups or different node pools that you are able to leverage within the same cluster, and then place your workloads heterogeneously with the scheduling and placement mechanisms that Kubernetes offers you. And finally, using things like spot instances, which is something that you'll see in a lot of cloud providers, where you'll have essentially this spare capacity that is offered to you as a lower cost, with a trade-off that it can be reclaimed at any given moment. So this is not suitable for every type of workload, but it is great for workloads that support this kind of disruption and are fine with the capacity going away and then being scaled back up, and are very resilient to this. And you can really maximize your efficiency and kind of minimize your costs if you're able to leverage these strategies together. All right, so let's delve into the first one, since I didn't really give great answers yet, just kind of the bullet points. The first one is really how to validate Kubernetes configurations. And again, this is a whole topic in itself. So I'm going to kind of use a few sample configuration checks as an example, and then we're going to jump into a bit in how to can actually apply this in production. Because effectively there's just way too many checks, and effectively these configuration checks will depend a lot as well on your organizational needs, on your workload needs, and effectively any compliance standards that you need to apply to. So let's take a look at a few very common ones. So the first one, just make sure that you have readiness and health perks configured. Make sure that you have resource quotas and limits configured on your workloads. Very basic things. Make sure you don't use like latest on image tags. And again, all of these could be very much their own webinar topic. Making sure that you have secure registry and scanned registry. Making sure that you have the pod security configured. And again, a lot. We're going to briefly discuss this one, but there's a lot that could be said about this topic. Making sure that basic Kubernetes hygiene is handled, like keeping your Kubernetes version up to date. Making sure that your nodes themselves are patched and up to date as well, and not just the Kubernetes version. So you need to kind of keep both in tandem. And then finally, making sure that all administrative access is minimized, and that's something that you can validate and audit. All right, so on to actual concrete solutions. What can we do? There's a lot of actual recommendation and validation tools out there that are absolutely great for this job. So a few of them call out, and you can then check the links on the slides when you download them after the presentation. Things like Polaris, KubeScan, KubeAdvisor, the Security DevOps kit are great tools that actually allow you, in some cases, actually give you recommendations of best practices and validations that you need to do. And in many other cases, they are actually able to make sure that your cluster is running according to those same recommendations, and so validate the configuration of that cluster specifically. So in this case, we're going to take a quick look into, and we're going to move into our first demo, and we're going to take a quick look into the DevOps Secure Toolkit. see if this is going well. And so hopefully you'll be able to see my screen. So what we have here right now is we are in a cluster called RBAC3. And this cluster is fairly simple, so it doesn't really have many things running. The pods that we have running here they have a bit of interesting names. So we have these two privileged container sensitive mount pods, and we have a few Azure Vote backend and Azure Vote frontend pods. So what does these pods actually do? So let's take a look at what these actually do. So that those specific pods are, as the name indicates, probably not the greatest thing to have running on clusters, and that's kind of on purpose for demo purposes. So you'll see that they're just kind of basic Nginx where I added a few tweaks to it. So for example, I'm running a few of them as privilege. In another case, I'm actually mounting some sensitive paths into it very specifically, and then I also added a few more nasty things like some very high privilege cluster rules for no reason whatsoever. And then I also bind that into a service account, again, for no reason whatsoever, except to demonstrate this. And in terms of the Azure Vote application, this is kind of your everyday simple application. So it's just kind of a Redis backend and a respective service, and just a simple web front end that is exposed by an ILB service. So really nothing special. And what we're going to see here is if we actually take a look at all the pods that are running in this cluster, you're going to find out that there's actually a few interesting ones right here. And in a specific namespace called AZSK scanner, which is a job that runs kind of as a cron job, and will effectively guarantee the assurance of your cluster. So what I did before this is I actually installed this continuous assurance scanner, and again you'll see details on my subscription and the actual RBAC3 cluster that we're looking at. And then what this effectively did, and you'll be able to see it here, is it installed the Azure Security Assurance for the cluster. In this case, it didn't because I already had it installed. So let's take a look at what exactly those, the result of those scanning efforts did. So when you take a look at the logs of that pod, again, probably as you'd expect after seeing the deployments I had in this cluster, you'll see that I pretty much failed almost all categories. So it's actually checking a number of things. For example, restrict container privilege escalation. You'll see obviously that one failed. I have one very specific pod to that. You'll see things like one thing that is actually good is that I'm at the latest Kubernetes version. So that's at least that I have going for myself. But again, I am using the default namespace to deploy applications. So even that kind of innocuous Azure Vote, even that one is not really following a best practice, kind of just something that might have slipped. This one will let you know, hey, that's not something that you should do according to best practices. You should probably put everything in their own namespace. And similarly, making sure that things are not able to write to the root file system and are not able to mount sensitive information into the containers. Then you'll see the information detail for each one. So this is essentially what I wanted to show you in this first demo. The reason why I want to show you this is because effectively on Azure, you're actually going to be able to see this same information in a bit more graphical way with tools like Azure Advisor, for example. So as you'll see here on the right, you'll actually get kind of a graphical UI into pretty much the same level set of information, and you'll be able to kind of navigate through it, even be guide to documentation. So it's directly from there, you're going to click Azure Advisor recommendations, and you're able to see a number of them that you already saw on the previous demo. All of this is on the GitHub page, and all the kind of both advisories as well as the DevOps Security Toolkit is on GitHub. Again, the links are provided above for you to check all the policies that it's running, to check all the recommendations and kind of all the heuristics that it's running inside of each cluster. A interesting thing on top of this is a specific security side of it, which is making sure that you have all the security recommendations, which are normally of kind of higher priority, in check, and that you have them all addressed in your cluster. So on Azure, again, another piece of integration that also drinks from this secure DevOps toolkit tool is Azure Security Center. And Azure Security Center will basically have all that information, and you'll see on the screen on the right-hand side, similar things to what you just saw, like, hey, I detected a new high privileged role, or hey, I detected new containers and new pods running in the kube system namespace, or I detected high privilege containers running. So all the same information is again in a graphical UI, and that then allow you as well, again, to do this at scale, which is to see this across all your clusters and all your fleet, and even get alerts based on it. So you can set up alerts based both on the advisor, kind of operational excellence and high availability concerns, as well as on the security center, more security focused alerts and recommendations. And it even allows you to kind of, or even protects you against a bit more advanced cloud threats, what I would call a bit more advanced cloud threat, which is, it's not just kind of warning you about things like, hey, you have a sensitive mount, as we just saw, or a privileged container, but it could detect things like well-known crypto mining images. And kind of these three things together really point to an attack or malicious attack on your cluster that might be exploiting it to, again, run crypto mining containers. And so this is actually a true threat that we've seen today, and we actually seen realized today several times. And so to have that kind of capability is really important, and how to have those checks is really important as well. Now, let's take a look then, how does this actually look? So when we actually are, I'm going to use the Azure portfolios as an example. So if we take a look at this, our RBAC 3 cluster, and we jump immediately into those advisor recommendations on the left-hand side, you're going to see, again, very similar feature set of what you saw just before. In this case, for example, hey, in this case, you are not running a support Kubernetes version, so make sure that you have your version within the GA supported versions, and you'll see a few security high-risk incidents that you also see on Security Center. So for example, hey, make sure that you have only a specific set of authorized IP ranges where you can actually access that API. And if you look at the alerts very specifically, you'll see, hey, these are pretty much exactly the same one by one, the ones that we saw before. As an example, we have a privileged container detected. Now we can actually introspect into it a bit more and see things like, hey, why is this alert triggering? How many resources is it affecting? Again, you'll see that name that you just saw before, that privilege, ASC privilege container name, and you'll see even how to take action against it. So again, it's transporting one of these tools, one of the open source tools to do validations, into how to apply that at scale to your fleet with ease. Again, a few tips if you're trying to get started with something like this and with a tool of this matter. Don't go all in. I've seen personally a lot of folks fail when they just decide to just alert based on everything and just try to attack everything at once. Start simple, start with a few very high impact recommendations. Again, maybe the security ones, maybe the Kubernetes version one, maybe some very critical ones that you see are really worthy of waking you up at night per se. And then just make sure that you notify the right folks and don't just spam everybody. And then build on that, iterate on that, maybe even build some automation, some functions, some runbooks based on that you can actually trigger automatically once those events kick in, and that's something that you can do with most of these tools as well. All right, so let's switch up into then policy management. So now we've seen a lot of the recommendations and alerts of things that you should be paying attention to and that you should be validating in terms of Kubernetes configurations. How can you actually enforce those as well? And how can you enforce those and manage those at scale? So the community has been investing a lot of time and effort into this area, and there are great solutions out there. You know, PA Gatekeeper, Caverno, Krail, and probably others. I apologize if I forgot. There are a ton of great solutions and efforts into this area, and they all kind of try to do the same, which is offer you kind of a policy mechanism to apply your enterprise requirements in a way that Kubernetes can understand and that can validate to make sure that your cluster is according to those requirements and to those standards. So The next level of that challenge is, again, if you look at something like each one of those solutions, they do a great job. You just install them in a cluster, and then you're able to make sure that each user kind of abides by those because they're being enforced, or you can turn an audit and make sure that you are auditing every action. The next level of that is doing that obviously at scale. You're going to see kind of this trend during this presentation. I'm going to be calling this out a few times, where the ideal scenario that I would envision normally is you have kind of an architect, and that's normally kind of that role, that security role in many enterprises. That would be the policy manager role. That would be kind of defining the policies, and that would be applying them either to a fleet of clusters or to a specific subsets, because maybe in many times you might want your clusters to all be the same. But the truth is, in many enterprise environments and in many cases, that's not exactly true, because applications have different requirements, business units have different requirements, subgroups have different requirements. And so while maybe a specific cluster that runs a specific application or set of applications is exactly the same as all maybe staging environments and QA environments, etc., it might not be the same of a set of clusters used by a different team. But nonetheless, you do need to have a same set of policies that are maybe company-wide and enforced company-wide that you like to apply to all of them, with exception maybe of the sandbox clusters or the developer clusters. And so this is the role of this maybe architect, policy manager, kind of don't pay too much attention on the name, that would be defining these policies, while developers themselves would just be using these clusters kind of safely, knowing that the clusters have policy protected. And again, then there would be great to actually have a mechanism to report back into the architect to say, hey, all these clusters are compliant, while that one is actually not. You might want to do something about that, or you might just mute that warning because that's expected. So again, without further ado, let's take a look at how does this look like. And we're going to use OPA Gatekeeper for this specific demo. So right now, we're going to swap into a different cluster. So we're going to go from RBAC3 into this policy one cluster, which has nothing running really. And I'm going to attempt to run two specific things. So I'm going to attempt to run this privilege Nginx, which is hopefully not familiar to you, which is just a regular Nginx with the privilege context, and unprivileged, just basic Nginx. So I'm going to try and run the privileged one first. And you're going to see immediately, hopefully in a few seconds, that is actually going to get an error. It's denied by policy. Why? Because it's running a privileged container. If you actually take a look at the constraint and the template, you'll actually see exactly which policy we're applying here. In this case, privileged containers are not allowed. And you'll see things like, hey, what is the enforcement action? In this case, it's deny. What are the excluded namespaces that you might put into it? So again, just full-fledged of OPA Gatekeeper capabilities. Similarly, though, unprivileged is also unallowed. And that is because there's yet another policy. In this case, the container image is not allowed. It comes from a source that is not allowed. So if you take a look at this actual constraint, you'll see that I have an image regex from a specific, very specific registry. So I'm actually able to guard which registries this cluster can pull images. So if I actually now add that into the image and try again, with some luck, this will actually meet all my policies, and effectively it has been created, and ideally it will be now running. So this was a very, very good example on how this works. Now, from a second cluster, let's say policy 2 in a different resource group, we could actually apply privilege. So that means that this cluster does not have policies applied to it. And you'll see that while I have my policy 1 right here already with policy enforced in this resource group, I also have policy 2 and 3 right there that are in a different resource group called CNCF2. Let's assume maybe it's a different business unit or a different team. And these two clusters actually don't have policy. So again, I could go ahead and install Gatekeeper in each one of them, etc., or even make some sort of automatic pipeline that deploys to all my clusters. Or I could just go ahead and leverage the integration with, for example, Azure Policy, where you could go ahead and apply both of these policies granularly to, say, the whole subscription or to a set of clusters at the same time. So the first one I'm going to do is actually basically the baseline from pod security policy, but through Gatekeeper. So pod security policy, as you know, is kind of in beta and likely to never graduate. But actually with Gatekeeper, you can get the exact same control. So here you'll see essentially all the controls from the baseline pod security policy, all bundled up into an initiative. And now what we're going to do is we're going to essentially select that resource group that has those two clusters. And at the same time, we're going to apply this baseline, this pod security baseline through OPA Gatekeeper into all those clusters at the same time. So we could select, so I could be a bit more permissive and say I just want to audit, again, depending on different environments, for example, or I can be very prescriptive and say, no, I'm going to deny anything that does not comply with this policy. And you'll see already the assignment has been done. So we can go ahead and test it out. But have in mind that that was not the only policy we had on policy one. So we actually had an image registry provenance policy. And now let's just take a quick look at all the built-in policies that you can do. Obviously with Gatekeeper, you can customize your own and do your own. And here you just have a set of already built-in and pre-created policies just to help you out get started without having to actually create your own. So this is the last one right there. The ensure only allow container images. And you'll see in this definition that as you might expect, this is going to actually have a constraint template and a constraint, again, basic Gatekeeper constraint and template. And they actually point to GitHub, which you can actually see here, and audit as well. So you can see exactly what these are doing, even before they're running in the cluster. You can access them and inspect them very granularly. And now let's go ahead and assign it. Now you could decide that, no, actually, this is a dev cluster. I'm not going to effectively apply this registry policy into it. Or you can decide, no, I want all my clusters, in this case, to be consistent and to have these two sets of policies applied. So we're going to, again, apply into this CNCF2 cluster. And this one, aside from deny, we actually have an additional parameter. Because again, you notice that I had that regex in my policy that basically allowed only for my registry and no other registry to have image pulled from. So I'm just going to be a bit lazy here, and I'm just going to copy paste and add my registry once more into it. And I'm going to create this policy. And so again, like policy one, now policy two and policy three actually have the exact same set of constraints. So if we, let's make sure we are in policy two and we try to deploy this privilege again, not possible anymore. And if we try to deploy this again, we'll get the exact same thing from policy three. And if we had 100 clusters in that resource group, all the 100 clusters would be effectively protected by the same policy right now. So this is policy enforcement and policy enforcement at scale. Right now, let's take a look at the last two topics here, which would be authentication at scale and effectively authorization at scale. So I tried to make it a bit more colorful, but I don't think I actually made OAuth 2 any easier with this image. But the point here is make sure you leverage all the goodness that is out there already. Kubernetes provides you with all these fantastic kind of plugs and knobs to integrate with existing directories, and it could be, as in the picture, Active Directory, but it could be with DEX, it could be with effectively anything that you use for your user management, and you could integrate it directly via the OIDC kind of parameters, or you could have your own custom authentication webhook server, something like GAR, for example, and you can leverage all of these different mechanisms. And my point here is that make sure that you do, because they're extremely valuable. I'm not going to make here a pitch on why central authentication is clear. I think there's been enough of that in the industry over the last few years. The next one, maybe a bit more nuanced, is authorization at scale. Again, Kubernetes actually provides you with very, very rich RBAC mechanisms that are Kubernetes native that allow you to secure, for example, what actions a user can do within a specific, for example, namespace, or what actions the user can do across the cluster, or maybe even a service account can do across a cluster, etc. Make sure, but in many cases, that obviously is internal to each cluster. Then the question becomes, once more, how to apply that at scale. And once again, a solution might just be to have a configuration management that ensures that all clusters have the exact same roles, have the exact same service accounts, bindings, etc. And that all clusters have that bootstrapping done as they come up and get that reconciled. But there are many other cases where you might want to have a different set of management where you don't want all your clusters to have that, or you want different clusters, or you want to have a more manual and direct impact to that, where you want to control that RBAC. And similarly, in many cases, and some of the tools that I mentioned above, actually, some of them provide that, is you might want to have slightly different RBAC constraints and mechanisms. For example, you might want a user to be able to only manipulate objects with a certain label. Again, that's not something that Kubernetes native RBAC supports. It already has all the flexibility you need for that, but Kubernetes does give you the possibility to hook in, for example, a custom authorization server that you could then make do whatever you needed to do. So we're going to take a look at how a custom authorization server would make your authorization scenario at scale much easier. So once more, let's take a look at this in practice. So we're going to switch into this RBAC 5 cluster, and we're going to do a get pods. Now you notice that immediately got popped up a login screen that prompts me to do a device login. So now you get to go with the joy of seeing me do the multi-factor authentication that I have with Microsoft. Now, after I do all of that, you'll see, oh, God, we actually got a forbidden response. And that is because this cluster is just freshly created, and my user has no permissions inside that cluster. There was no bootstrapping done whatsoever. So effectively, that user that you just saw has no permissions. But if we jump into its IAM blade, and if we jump into the roles that I can give them, we actually see that we have a number of RBAC roles, and especially this reader role that I find very interesting because it's exactly what I need. I need to see things all across this cluster, but I don't actually need to do anything to it. So I'm going to apply this reader role, which is essentially the same reader role that you normally find on the built-in rules from Kubernetes. Allows me to see anything except secrets, so that I don't elevate my privilege. And you'll see things like the admin role or the writer role, which allows me to pretty much change objects without elevating my privilege or changing anything with regards to authentication, authorization. And these are all built-in roles. You could actually build your own custom role if you want by effectively leveraging all the actions that you know, and all the API groups from Kubernetes that you know. So for example, you could say, hey, I can do deployment read and deployment write, but I cannot touch daemon sets, for example. And you can make a very customized role for that. Now, if you do get pods, now actually I'm able to list pods. I'm actually able to list nodes, and I can even list pods across all namespaces and see them happily running. But if I actually try to deploy my vote application, I can't. Again, I'm just a reader in this specific cluster. So apparently I do need a bit more permissions. So let me get the ID of this cluster really quickly, and let me apply an additional permission. But in this case, it's going to be the admin permission, but not to the whole cluster. I don't need that. So I'm going to very granularly apply it to the default namespace where I want to deploy my application. And after that is done, I'm actually going to be able to reapply this YAML. And at this time, I'm actually able to create this. But if I try to, for example, create a namespace, I'm not going to be able to, because once more, I only have admin access to default. To the rest of the cluster, I'm only a regular reader. Now, this was one cluster. I could have done anything I just did really with Kubernetes RBAC. Now let's see applying this at scale and doing this without any bootstrapping. So I have this RBAC 6 cluster. I'm going to do the exact same mechanism that I did for RBAC 5. I'm going to go ahead and add a role assignment, and I'm going to do it for the whole resource group in this case. And once more, much like policy, I could do to a whole resource group or to a whole subscription, to the whole fleet of clusters or to a specific set of clusters, depending on what my needs are as a user. And then the admins could actually control that very easily. So I've just done that, and I'm going to switch to this RBAC 6. I'm going to spare you the joy of actually having me go through the loops of multi-factor authentication again. But effectively, this is the first time that I'm logging into this cluster. There is no, as you can see by the prompt, there's no bootstrapping that I did to the cluster whatsoever, except actually adding it directly from outside the cluster. But at this point, I'm already able to list pods, but not to apply YAMLs. So exactly the permission that I wanted to have and that I can apply at scale very, very easily. So if a new user gets in, I can just immediately grant them read access and then go ahead and grant them admin access to specific clusters, or even play around with situations like just-in-time, where you could give a user just-in-time access to a specific namespace or to a specific cluster to perform a high privilege action just during given a period of time, and then his privileges revert back into the standard, which could be, for example, reader access. And reader access could be used, for example, to get logs and to just inspect the applications without actually being able to modify them. All right, so obviously the next part of this, if you're looking at production, is obviously diagnosis and troubleshooting and how to make sure that both your cluster is healthy and your applications are healthy. And once more, this is in itself a whole topic for a full presentation. So I'm not going to, much like on the rest of them, dive really deep. Just going to make a few considerations and give a few examples. Again, the great tools that you have out there: SysD, WeaveScope, Periscope, and AKS Diagnostics. All those open source tools that you can go ahead and use in your clusters. And you can actually then leverage similar integrations that I mentioned before for Advisor and Security Center for example, Periscope and AKS Diagnostics. So you can see a page where you can, even from your VS Code editor, you have your Kubernetes extension and you have your Kubernetes clusters listed there. And you can go right ahead, right click, and see diagnostics for that cluster running in Azure. And you'll see pretty much the same page that you see in screen. And you'll see, for example, hey, this cluster is healthy. So you kind of run a full checkup on that cluster. Cluster is healthy, workloads are healthy, no problems whatsoever. Or otherwise, you'll actually see some red alerts. For example, your network configuration has an issue, or you're running out of IPs, or your outbound connectivity is failing, and even some recommendations on next steps and what you can do as potential solutions. Now, for our last point, which was fairly interesting, which is efficiency and cost savings. So let's imagine that on our cluster, you actually get a recommendation such as, hey, make sure that you enable Autoscaler. Again, as I mentioned, that's the easy part. You can just go ahead and enable Autoscaler. The more nuanced part, and where you're going to still get a lot of benefits that a lot of folks are not leveraging, is making sure that you are leveraging that heterogeneous capabilities of Kubernetes and of the infrastructure itself, making sure that you're using different node queues and agent groups and node pools that have the right size VM for your workload. They can then place there. And similarly, leverage all the tools that Kubernetes gives you, like Cluster Autoscaler and the ecosystem as well. Cluster Autoscaler, horizontal Pod Autoscaler, using combination with something, for example, like Virtual Kubelet, which is a sandbox project from the CNCF, to create a virtual, if you will, node that you can then burst into, and that virtual node will then point into a service. So we'll take a look at that in a second. And then use that even again more in combination with things like Descheduler, where you could use it to respond to unbalanced clusters or unoptimized clusters. Because again, the Kubernetes scheduler will respond to effectively what the current state of the cluster is. So if you have two applications and one of them is very scaled up, and you have a nice set of affinity or node selection happening between those two applications, when that second application starts to scale, the scheduler will take decisions based on the current state of the cluster, which was application one was fully scaled out. So that might not be the best selection for scaling up application two. And when application one scales back down, then we get stuck normally. We get stuck with the balancing that happened on application two. With Descheduler, you can actually reshuffle that in runtime by running kind of a cron job or a job that will periodically check if everything is according to your policies. Again, something like, are you respecting your affinity? Are you respecting the pod age? Are you respecting the number of restarts? And based on that, you can take actions as well automatically and keep your cluster balanced and optimized. And then finally, there's even very interesting projects like KEDA, Kubernetes Event-Driven Autoscaling, that actually allow you to optimize your scaling based very much on your workload architecture. In this case, for example, be event-driven. So instead of actually having something running there with one replica and then just waiting for CPU or memory or for some custom metrics that you can put into HPA, you can actually use KEDA to, for example, respond to an external trigger. And then based on that, scale from essentially nothing, even 0, into the necessary number that you get to. Now, if I went a bit too fast, I'm going to go and do a quick recap for you. So horizontal pod autoscaler, most of the folks on the call know what that means, but quick recap, it's basically how you can autoscale your deployments based on their metrics. So it actually is monitoring by default Kubernetes metrics server, collecting all the metrics from your pods, and then based on that, it will actually take decisions into scaling up or down the number of replicas of your deployment. Okay, so easy enough. It will just scale your deployment up and down based on the usage that your application is having from a memory CPU perspective, but also you can hook up specific metrics to it as well. Now, cluster autoscaler itself then is about the infrastructure side. If you're scaling your deployment kind of rapidly, what happens to your nodes? So cluster autoscaler actually looks at pods in pending state that have no place to go because you run out of nodes, and it will actually talk to the infrastructure provider, depicted in the picture is Azure, but could be other infrastructure providers that support cluster autoscaler, and it will actually add more nodes based on the number of pending pods and what their requirements are specifically. Now, if we then add something like virtual kubelet, which again, I recommend that you take a look at one of the sandbox projects of the CNCF, now things get very interesting because aside from having those nodes, you can actually have this virtual node where you can burst into. So that virtual node, as I mentioned, can actually talk to an API, like in this case, Azure Container Instances, which is essentially Docker Run. For those of you that don't know what container instances are, it's like Docker Run in Azure, where you can just send a container, run it there, do ACI run, and it runs. Kubernetes can actually leverage that too, because essentially what it needs to do is to place pods and containers as well. So instead of just putting them on actual nodes, it will just use this virtual node to talk to this API and place them into that service itself. And with that, kind of virtually creating an infinite node that it can use. Now, this is great for bursting. Obviously, if we take a quick peek back into optimization, which is what we want, you probably don't want to leave these pods running for a long period of time in these additional services. You want to maximize, once more, your actual infrastructure, which is where you can get the most savings from. And so you'd like those to actually come back into the nodes. And so once again, remember what I mentioned, you can actually use Descheduler and similar projects to do that kind of balancing after that is done. So you can, for example, use a combination of cluster autoscaler, virtual kubelet and virtual nodes, and Descheduler to actually make sure that you are able to respond to that burst and to the very fast demand, because effectively what virtual kubelet delivers versus cluster autoscaler is that cluster autoscaler needs to provision nodes and they need to come up, even if they're VMs, which is pretty fast. It still takes a bit of time. In the case of virtual nodes, it's just, again, it's just Docker run. So you know how fast that is, just a few seconds and you get more containers running. So it's very, very appealing. But again, to maximize, you'd probably want to bring those back into your actual nodes, especially for long running purposes. So again, with Descheduler and cluster autoscaler, you can follow up on those bursts and then balance your cluster back into a more efficient and optimized state. And then finally, things like KEDA really kind of bring a different level of abstraction and bring a different level of tuning and workload aligned scaling, where you can actually have external triggers, where you can actually go from 0, so you can have your deployment all the way at 0 and then occupying absolutely nothing. And then after that, just scale it based on an event up to 100 or whatever number of replicas you can go to. And again, you can use this in any Kubernetes cluster. It's also an open source project that I linked to and that I recommend that you test out for your workloads, especially if you're doing any sort of event-driven programming or you have any event-driven architecture in your applications. All right, so for the last demo, I just want to quickly show what this looks like. So let me just switch into our first cluster. So what you'll see here is you'll see I have already a few instances of my store running, and you'll see I have Prometheus running, and you'll see something interesting, which is in terms of nodes, I actually have only 3 nodes right there, and I have a virtual node right there. So let me actually go ahead and get this off. And I'm just gonna produce some load. And after some time, we'll actually should be able to start seeing a lot of these pods starting to come up. So I know we're close to time, so I do want to leave some time for questions. So I'm going to leave this one running and allow you to ask some questions.
Are you going to go through the takeaways, or is that just to be on screen?
Yeah, that's just to be on screen.
Okay, well, thank you for the presentation. We'll now take some time to go through questions. As a reminder, if you do have a question, please drop them into the Q&A box at the bottom of the screen, and we will get through as many as we have time for. So George, first question, do we have similar controls and other stringent policies for Service Fabric? Also, in general, for Azure novices, would you suggest to deploy containerized apps to Service Fabric first, then to AKS?
It's all dependent on obviously your needs and workloads. There are 2 different services. So from a purely Azure perspective, this presentation was obviously focused exclusively on Kubernetes. Azure has a load more services that are fit for purpose of specific workloads. I have app service, web apps, it has functions, it has Service Fabric. And so I, as a generic rule of thumb, and I think that's valid for everything and every cloud provider, is choose a service that is more fit for purpose for your workloads. Again, if Kubernetes has a tremendous ecosystem right now where effectively you can run anything there, which is one of its great advantages, and still run it with the same confidence. But again, if you're looking for super simplicity and just a way to, for example, ACI was something that we mentioned here. If you're just looking for something to run a container, there's really no point in setting up a full Kubernetes cluster. You can set up something locally with like Q3ES or with Minikube or something similar, or you could just do something like ACI run on Azure. So similarly, the same would apply to Service Fabric. Service Fabric is a bit more about running microservices more than containers itself. It happens to run containers, but it's essentially a microservice platform that is enterprise ready for that.
Great. So next question we have, someone asked, is there a default HPA metric server that Azure provides specifically for custom metrics?
Yeah, we do have, and I'm happy to then link it on the final slide version. You can, it's a GitHub project as well, public, with just custom metrics Azure, and you'll get custom metrics based on kind of Azure specific metrics and signals.
Great. And then follow-up question, is there a plan to offer Descheduler as an AKS add-on, or sorry, as an AKS add-on?
Not as of right now. We haven't got any large amount of requests there, and we kind of are very happy when folks run the full spectrum of Kubernetes solutions in their clusters. We're very committed to make sure that AKS is 100% vanilla Kubernetes. But it is something interesting. If that's something that that you see as a very interesting piece for you and for your clusters, just let me know. My GitHub handle, I believe, is on the beginning. So just hit me up on Twitter, and I'm happy to chat about that. So it's definitely a possibility, but not something that we're looking at right now.
Great. I think they meant to ask this as a question. Do you have any best practices to prepare for failover of a cluster in a worst case without coping or without coping / replicating everything, especially Azure resources for production usage?
Yeah, so definitely BCDR scenario is once more one of the interesting challenges that we see in Kubernetes today. So what I would normally, and once again, I don't have a great just canned answer for it. It really will depend on your needs, on your workload needs, on your RPO, RTO needs. A common architecture or high-level architecture that we normally see is folks running kind of an active-active cluster where they actually have the second one really slimmed down, again, to have costs to a minimum or even to zero if possible. And then just in case of either disruption, but it can even help in cases of high load, having that kind of like a traffic manager or DNS load balancer point to two active-active clusters and have that second one really scale aggressively if it needs to come into play and to help out the main cluster or in cases of disruption. Then obviously the recommendation, again, if we're looking at it from a pure Azure perspective, is to have a lot of the services that you use with your cluster. If you're looking at something like data or similar, to use something like geo-replicated services like Cosmos DB, etc., which would make your job easier, because otherwise then you need to have a BCDR mechanism for storage and for stateful sets and persistency, which you can then apply with things like, for example, Valero or similar backup solutions, but then you need to automate that specifically. So normally we've seen more success with kind of this active-active and then geo-replicated services on the back-end architecture.
Okay, I'm going to do one last question, given the time. Is there documentation available that shows the overlap and or differences between OPA and Azure policy?
Yes, so there is documentation, and it is linked on these slides as well. The difference is not a difference, so they're not two distinct services. I want to make that clear if it wasn't during the talk. Azure policy is merely using OPA and merely providing you with a interface to use OPA at scale. So they're not two distinct services. In fact, the link and the pages that I showed actually show the exact OPA constraints and templates that Azure policy is applying to your clusters, and you can see them on your clusters running after it's applied. So Azure policy obviously is a more broad service that you can apply to all Azure services and control all kinds of different things. From a Kubernetes perspective, internal to cluster, it literally uses OPA gatekeeper to make sure that its policies are enforced and to get also the audit endpoint and make sure that it has an endpoint to audit them as well. So they play together. They're not two distinct things. And I know that this was my last question, so I do want to make sure that folks know that if you need to post any additional question or you want to continue, just make sure to reach me out on Twitter. Really happy that you gave me this time, and thank you very much.
Yeah, thank you, George, for a great presentation. That is all the time we have for today. And thank you everyone for joining us. As a reminder, the webinar recordings and the slides will be online later today. And we look forward to seeing you all at a future CNCF webinar. Thanks and have a great day.